we continue the analysis of sensitivity, we have discussed how the parameter changes would affect the objective value, the total cost. Now let's discuss about if some decisions or parameters contain errors, how this error would affect the results. So first, here we have the expression for the objective value and then the optimum decisions. So here we can see the decisions are two cases. For the second case, the decision is relatively direct, which is bounded by the capacity. And then for the first case, it is relatively complicated due to the parameters of holding cost and fixed cost. So let's try to focus on the error analysis of the first case. So assume that the decision we made is a factor times optimum decision. Since we consider the first case, this is just the square root of fixed cost divided by holding cost and then the demand rate. So here that indicates if gamma is near 1 but is not 1, then our decision has some kind of errors. So let's see how this error would affect the objective. So now let's see how this gamma would affect the total cost under the decision with errors. That means we need to evaluate the new objective divided by the optimum objective. To calculate the new objective, we just plug in these functions. So except the cost associated with the decision variable headway, we have two constant terms. Okay, the two constant terms here are somewhat reduce the error in the estimation of our objective. So for example, let's see if the two constant terms are dramatically huge, let's say it's almost infinity, then the decision variable does not affect the results. The ratio is always 1. Okay, so without the derivation, we can tell you that if we just ignore the impact of this two constant, the estimation on the error of the objective should be larger. So that means it provides you with the upper bound of the error. So in this sense, we just ignore the two constant terms. So after simple derivations, we can show this value is a half times gamma plus gamma inverse. This is a very famous expression in the sensitivity analysis of a UQ model. So this tells you that the error of the objective is relatively small comparing with that of the decision variable. Let's plot the error of the objective with respect to the error of the decisions. We know that when this 1, that means there's no error, the objective should have no error. So this is also a 90 shape. Let's see if we have the decision error, means our estimated headway is greater or equal to half of the optimum headway and smaller or equal to 2 times the headway. So in this sense, our objective error, which is a ratio, this gives us 25%. So that means if we have this half or 2, this gives us 1.25. Okay, and then if the decision only have 25% error, so it means this point. So this gave us a value of 1.025. So that indicates we only have 2.5% error for the objective value. So that means as long as our decision is not too far away from the optimum decision, optimum headway, your objective value should be pretty close to the optimum total cost. Now let's see the impact of the input parameters. So let's see if we have an error in obtaining the parameter CF, which is delta times the real fixed cost. Here we also have this parameter close to 1. So the error of the parameter estimation has two impacts. First, it will affect our decision, and then second, it will affect our objective. So for simplicity, we will first analyze how it affects our decisions, which is our gamma, under the change of delta. So to this end, we know like our expression of the optimum decision is given by two terms. Okay, so when it is in the second case, the estimation of the fixed cost will not have an impact on the decisions. So no matter how the fixed cost changes, our optimum decision is only bounded by the capacity and then the demand rate. So similarly, we will just focus on the first case. So from the expression, we can immediately get the expression for gamma with respect to the estimation error on CF. So this gives us square root of delta. So this indicates the impact of the fixed cost is even less sensitive than the impact of the decision variables. So for example, we have, this is 50%. So that means delta belongs to 1/2 to 2. So under this case, our decision error, we can have gamma greater or equal to square root and square root of 2. So this gives us around 0.7 to 1.4. A further impact on the objective, so the impact on the decision is around 40%. And then the impact for the objective will be in this expression. We can get is around 10%. Okay, so that indicates sensitivity for the parameters is even lower than the sensitivity of the decision variable. So similarly, we can do the analysis for the holding cost, because holding cost is also in a square root, which is similar. Because when delta is around 1, the inverse of delta has a similar impact with delta.